Hello friends, welcome to my YouTube channel. Today the problem that we are going to discuss is linked list cycle, problem number 141. Let's read out the problem description first, which says given the head of a linked list determine if the linked list has a cycle in it. These all are unnecessary details. Return true if there is a cycle in linked list, otherwise return false. How the cycle in a linked list will look like? It is something like this. So here there are four nodes, you can see 1, 2, 3, 4, and there is no end node which is pointing to null, right? So this -4, this node is again pointing to 2, okay, and this represent a cycle in a linked list. So for this problem our program should return true, and likewise for this also. But for this example, since there is a one node and there is no cycle in linked list, so we have to return a false. Follow-up question is, can you solve it in big O1 in constant memory? So we'll be discussing both the approaches. Like first we will go with the brute force, and then we'll try to make it more efficient, right? So let's get started. Through Blackboard. So first approach we will be discussing the brute force. This is the same example we have taken from the problem, and we are taking a slow pointer, which is basically a head pointer. It is basically pointing to head right now, right? So we'll be storing the address of each node into one hash set. The set is having only unique addresses, right? And as soon as the duplicate address will come, we'll get to know there is a cycle, right? So first of all, for this head, we will be storing the address which is slow only. In the next iteration, slow will be pointing to this node, right? So we will be storing slow.next right here. We have to store the actual address of that node. We will be checking in our hash set, like is that value is already there, and if that is the case, we will return a true. So in that way, we can say like there is a linked list cycle, but this approach will take big of n time, big of n time and big of n space also, right? So this space is extra. Can we eliminate this space? We have to come up with some approach where we don't have to save these address of these nodes. And yes, there exists an approach that we're going to discuss. So let's discuss the efficient approach, which is using two pointers. So here we have, you can see we have two pointers defined as slow and fast, and both are currently pointing to head, right? So slow is also pointing to 3 and fast is also pointing to 3. So in case of two pointers, and as the name suggests, there are slow and fast pointers. So the property of slow pointer is that it will be moving one node at a time. Okay, so slow is moving one node in one step and fast is moving two nodes in one step. Okay, so let's say in first step or in first iteration, slow will be pointing to this node, right? Because we move one node at a time, and fast will be pointing to this node because two nodes at a time, right? Now in next step what will happen, and so we have till now we have completed two iterations or two steps, two iterations, right? Now what will happen in third one? So this will be in the third iteration, right? So what actually it is happening is this fast will be pointing to 2, right? Let's see that. In the next step, fast will be pointing to 2 and slow will also be pointing to 2. Okay, so as soon as this condition occurs, like both slow and fast are pointing to the same node, then we say there is a cycle occurs. Cool. So we will try to quickly see the Java code for this approach. You can solve it in any preferred programming language you want. So yeah, let's quickly jump to the editor. So here is a method and has cycle, and its return type is boolean, and it is having list node head. Right? So first we will check if head double equals to null, then return false from there itself. And as we have explained, we are taking two pointers. One is named as slow pointer and other is named as fast pointer, and both are initially pointing to head. Right, and we'll be moving slow pointer one node at a time and fast pointer two nodes at a time. And if slow pointer double equals to fast pointer, then return true. And if it doesn't satisfy, or if it comes out from this loop, that means it doesn't have any cycle, and in that case we will return false. But in this whole code, this condition matters a lot. So we will see how we have come uh, to this condition, right, where fast pointer not equals to null and fast pointer dot next not equals to null. So in either of the false condition, we will not go inside and we will return false. So let's see two examples. So yeah, here we have two examples. In the first example, there are odd number of nodes. In the second example, there are even number of nodes. Right, and uh, when we try to iterate our linked list using slow pointer and fast pointer, and in the first iteration only, our slow is pointing to the second node and fast is pointing to the third node, right? And we can see fast dot next is equals to null, right? And if we try to again iterate, slow pointer will be pointing to here and fast pointer will be pointing to null, right? So in this case only we have to uh, come out of the loop, or we can say we should return false, right? So that's why for even number of nodes we have written this fast pointer dot next not equals to null. So in odd number of case, in odd number of nodes, fast pointer dot next double equals to null, that we already see. So this condition will false and we will return false. Now in case of even number of nodes, slow will be pointing to the second node and fast is pointing to null. Right? So here fast pointer not equals to null. So here it will return false, and this condition won't satisfy and will return false. This condition is pretty important in whole code. As you can see, this the whole code is pretty simple, but because of these two examples, we can see we can add this condition easily. Okay, now try to run this code. I hope it should satisfy all the default test cases. Yeah, accepted. Now try to submit this code. Okay, pretty good. So it's faster than 100% of Java Online submissions. Yeah, so that's it, friends, for today. I will be providing the solution link into the description. You can go through it.